Welcome to Cool Guy Podcast, the great danger from Antarctica's melting ice.
Today we're heading south, way south, to what people often call the most undiscovered continent on Earth, Antarctica.
And our mission really is to look at the dangers of its rapid melting.
Because it holds, what, 70% of the world's fresh water?
70%. And you hear about the Doomsday Glacier, right? It's shedding something like 50 billion tons of ice every single year.
50 billion. And global temperatures are rising, but the jump has been most dramatic right there in the Southern Ocean.
It really has.
Okay, so let's unpack this. If the threat is so immediate, what's actually driving the melt, and what are the catastrophic consequences that might already be locked in for all of us?
Well, the biggest concern is the West Antarctic ice sheet, the WAIS sheets. A lot of it isn't on dry land. It's sitting on the seafloor, which makes it, really unstable.
So if that were to go completely, what would that mean for sea levels?
You're looking at a rise of 18 to 20 feet globally. And the key mechanism isn't even warm air. It's warm, deep ocean water that's getting pushed up onto the continental shelf and attacking these glaciers from underneath.
So it's melting from the bottom up, thinning the part that floats.
Exactly. And when that floating ice shelf thins, it reduces the pressure, holding back the grounded ice. So the whole glacier just speeds up.
That's a feedback loop.
It is. And scientists are now warning we may have reached a state of hysteresis.
A point of no return, basically.
Essentially, yes. Some research suggests just a 1/4 degree Celsius of extra ocean warming could lock the WAIS into a 4-meter sea level rise. It becomes irreversible.
That's a chilling thought. So we've talked about the physics, but the really interesting part, I think, is what's hidden beneath the ice.
Oh, absolutely. Beneath 2 kilometers of ice, you find this incredibly complex world. There are enormous canyon systems, rivers bigger than the Amazon.
And a huge number of volcanoes, right?
One of the largest volcanic regions on Earth, yeah. And here's the dangerous part. As the ice on top melts, it reduces the physical pressure on the Earth's crust.
Which could trigger more eruptions.
Like eruptions.
Yeah.
Which would then melt even more ice from below and, lubricate the ground so the glaciers slide even faster.
And it's not just volcanoes. What about the things that have been frozen in that ice for, millennia? Pathogens, viruses?
It's a serious risk. Some ancient bacteria they've found carry traits for things like antibiotic resistance, and our immune systems have never seen them. If those traits jump to modern bacteria,
that could be a global health crisis.
It could.
And the immediate impacts are ecological too, right? We're already seeing it.
Look at the krill. Just a 1/2 degree rise in water temperature messes up their reproduction.
Yeah.
And krill are the food source for pretty much everything there.
So you get this domino effect on penguins.
A 50 to 65% drop in some penguin populations. It's devastating. And you hear these stories of suicide marches where lone penguins just walk inland trying to find a new home for their colony.
And it goes all the way down to Antarctica's largest land animal.
A tiny wingless fly. Yeah. It's dying out because the exposed rock is getting too warm and dry for it.
But it's not all hopeless. We've seen international cooperation work before. The Montreal Protocol fixed the ozone hole.
It's starting to, yes.
Yeah.
And that success is inspiring some really interesting geoengineering ideas. Things like biodegradable glacier blankets or even pumping water back onto the ice to thicken it.
So there are options. I saw one study that put the economic cost of climate change at around $130 trillion over the next 3 centuries.
Right. And the estimated cost to scale up some of these geoengineering efforts, maybe $500 billion, the math seems pretty clear.
So what does this all mean?
It means Antarctica isn't some isolated frozen wasteland. It's a critical global system. And we have evidence that this has happened before.
From octopus DNA, of all things.
Yes. It showed that the Ross and Weddell Seas were connected about 125,000 years ago, when temperatures were pretty similar to today. That means the WAIS collapsed. Sea levels were up to 10 meters higher.
So the question is, if it collapsed then, under similar conditions, why wouldn't it happen again?
And that leaves us with a final thought for you. The choice seems pretty stark, doesn't it? Do we absorb $130 trillion in future losses and displacement? Or do we make a $500 billion investment now to buy ourselves time and maybe, just maybe, save the West Antarctic ice sheet?